Let me see. Mic test. Okay. All good. Okay. Can yeah. So what do I want to talk about? Right. Okay. So now I'm back to this set of notes. Let me show you the name of the notes. Okay, over here, 221021 Trigo notes, Brendan. So this is still the same set of notes, but I need to add on something. Okay, I need to add on something, in particular to the Trigo identities. So let's take a look. So what have we learned so far? We learned about Pythagorean identities, these three fellows, right? The ones involving the squares. And then after that, we also learned about the compound angle identities or the addition formula, the one involving plus minus, right? Sine, cosine, and tangent, right? And then after that, we learned about the double angle identities. We replace the b there with a, so we get a plus a, which is 2a and that's summarized in the formula list. The three types of formulas. This one, and this one. Right now, I need you to have an extension. This is slight extension that's maybe overlapping a bit with A levels, but it's required for one of the questions. Here is a trick you need to know. Let's take a look at one such identity. Okay, this one, I will call this the soft version of product to sum formula. Also known as the, what do you call it? Factor formula. Yeah, factor formula. You can go and Google this if you want. But let me just introduce it to you. So the basic idea here is to realize that if you recall the addition formulas over here, let me just copy it down so I don't have to rewrite it again. Like this, right? Now you have all these formulas, 1, 2, 3, and 4. Okay, I'll just use the specific one so that it's easier to understand. Now, the key idea here you need to observe is that there's a lot of repetition, right? Do you see? Like on the right hand side? No, the same. Some of them look the same. Let's just label them 1, 2, 3, 4. Then let's see if we can figure out anything funny about it. Tell me, what is 1 plus 2? Of course, on the left-hand side, it will be just sine A plus B plus sine A minus B, right?
What?
But is it clear, this one? But what about the right-hand side?
Cancel.
Yes, exactly. They will cancel off. Something cancels off. These guys will cancel off, right? So that means that you're actually just left with how what? Exactly, 2 sine A cos B. Okay? The cos A sine B cancels. So what does it mean now? That means if you just make sine A cos B the subject, actually this is all you need. This is the key pattern you need to observe in order to solve one of the questions in the exercise 9C. Or one of the more difficult questions. Yeah. But that's all you need. That's why I said soft version. But the full formula, the full form of what we call the product to sum formula or the factor formula is the following. You divide by 2. I guess it's not that much of an extension. Just divide by 2. So what you end up with is sine A cos B equals to half bracket of whatever on the left-hand side. The sum of those two formulas. Is that clear? So you have a brand new identity. It's not that difficult, right? You've already done so many practice. I'm sure this is nothing new to you. It's just another random identity, right? But this is very, very, very useful. Reason being, what is it? What was the reason? Right. The angle A here in relation to A plus B and A minus B, right? There's a special relationship. If I do a simple substitution, like let's say I let P equals to A plus B, and I let Q equals to A minus B, I can do something funny to it. Okay, let me just demonstrate. I just need this updated formula. If P equals A plus B and Q equals A minus B, we can do the following. this formula now updates into half bracket sine P plus sine Q. Agree so far? Equals to sine A cos B. I'll just leave it as that. But here you need to make a very critical observation about this P and Q. What if I take P plus Q, then I divide by 2? What is this equal to?
A.
Exactly. It's A. Oh, you can tell immediately. Very, very good. So A plus B, you add on to A minus B, and you divide by 2. The B will cancel away. You're just left with 2A plus A, which is 2A divided by 2, which is just A. So that means you can actually replace the A there with P plus Q divided by 2. Okay, how about for B? Can you come up with a similar formula? What do you think is B? A is P plus Q over 2. Can you come up with something similar?
P minus Q.
And then?
Divide by 2.
Exactly, correct. P minus Q, then divide by 2. This, you have just learned a new identity. It's called the product to sum formula. You need this in A levels, H2 math, and engineering math. But AMAX don't need. I just give a little bit extra because I realized you actually need to know how to derive this on your own in order to solve one of the questions I gave you. You need to derive this on your own. Quite a big jump, but okay, this one is clear, right? B plus B divided by 2 is just B.
Okay.
And all. So therefore, you get this fancy new formula, and there are 4 other versions of it. Sorry, 3 other versions of it. This is the first version. Okay, I'll take number 1. There's still 3 other versions, but not very relevant. Not very relevant. I will not talk more about it. You can go and Google for this. Or if you want me to continue teaching you for A-level content, I can also review more. Okay, it's just taking different ways of combining the 1, 2, 3, and 4. Because you can notice the pattern. This one cancel off if you add them. Or this one, there's an overlap. So if you just minus, then these 2 will cancel off. Or sine A cos B and sine A cos B repeat. So you can minus and then they'll cancel off. Right? Then you're able to deduce all the other identities on your own. With the substitution P equal A plus B, Q equals A minus B, and A is equal to P plus Q over 2, and B is equal to P minus Q over 2. You can derive on your own, or just Google for it, the formulas. Can? Okay,
Okay.
I'm gonna move on. So now, that was relevant to the trigo exercise. Question: do you want me to go through with you the mistakes in the Swiss Cottage paper 2, or do you want me to go to the trigo exercise?
I'm okay with anything.
Anything else? Okay, then I'm just gonna clear the tree or the whatever. What's that school called? Swiss Cottage, because it's been quite a while. Okay, I just quickly finish up. Not a lot of mistakes. Okay, all right. I assume that you have already downloaded and read through. Okay, most of them are correct. Okay, but one part I think you forgot. For 7 part B, they are asking you, when is this expression strictly more than this other expression? So this is the inequality that they're asking for. That you have to write down. You have to translate from the questions, which is written in English, into this mathematical inequality. Is this part clear to you? 7B. Maybe you go open up the file first.
Yeah.
I also need to find the file. Swiss Cottage, where? Yeah. Right, so that's the inequality. Is that inequality okay so far? The range of values of k for which x squared plus 12x plus 9 is always greater than 4x plus k. So that means that after you have this inequality, what they're asking you to solve for is solve for x. But then you realize a problem. If you try to want to solve for x, you always make sure right hand side is a 0, right? So you just bring over, as per usual, 4x plus k bring over. You end up with 1x squared plus 8x plus 9 minus k, more than 0. Then you want to solve for x, and that's when you encounter a problem. Here got a k, I cannot solve. So what do you need to do? That's when you have to understand what it means when they say a quadratic is more than 0. Do you know what it means?
quadratic is more than 0.
Yes. What does this mean? You can think of it like this. This
Y
guy
is
here,
more than 0.
y is more than 0, right? You can think of this as y1, this is y2, and y2 is equals 0, which is x-axis, and y1 is the quadratic curve. Y1 is the quadratic curve, y2 is the x-axis. When we say more than, it means we want the quadratic curve to be above the x-axis. So and because there's a coefficient here, x squared, coefficient of the x squared term, which is positive 1. Positive tells you it's a happy phase, right? So the only possibility for the graph is either of these possibilities. Happy phase that's above x-axis, right? Which means what? Is there an intersection with the x-axis? No.
No.
So no intersection means no what?
No range of values.
No, I wrote here already. No real.
No.
Remember the three cases on our b squared minus 4ac? Three cases. It's more than 0, equals 0, less than 0. It's referring to two real distinct roots, two real and distinct roots, or only one root only, what we call repeated root. Then the last case is no real roots, 0 real roots. Okay, so here, because there's no intersection, therefore there's no roots. So it's this case, b squared minus 4ac less than 0. So you are supposed to know this from theory. Need to translate from here into here straight away. And then you substitute the a, b, and c, and you solve for k, which is what I did here. Is it clear, the procedure?
Okay.
And this is the part I think that you should be stuck with. You need to remember, when you say quadratic is strictly more than 0, it means b squared minus 4ac less than 0. The rest you should be able to do. Okay? This is question 7b, paper 2. So yeah, okay, moving on. Next, sum of roots, product of roots. I can't remember if I went through with you. This is a topic that has already been removed from the syllabus, but did I go through with you before?
I think so.
Oh, I did. Okay.
I think so.
Yeah, so basically you need to remember this guy here, the conclusion. A quadratic equation is always of this formula. 1x squared, okay, positive 1x squared, minus away bracket sum of the roots multiplied by x, plus bracket product of the roots is always equal to 0. Okay, this bracket is not needed, but this bracket is needed. You must have a minus in front of the sum of the roots. Okay, must multiply a negative 1. Okay, so this is the final conclusion, which is the quadratic equation that they are looking for. And the roots in this question 8 part 2 is a cube and b cube. Alpha cube, and it should have been beta. They put wrongly. It should have been beta, not b. Alpha cube and beta cube. Okay. And what you have done is you managed to, you know that you need to go and find the sum, right? So alpha cube plus beta cube, right? But then you got stuck. How can you make use of information given about the alpha plus beta and the alpha beta from the original quadratic equation to deduce what is alpha cube plus beta cube? The trick here is you need to realize you can use the SOAP formula. Do you recall the SOAP formula? Sum of products, sum of cubes. Then you can factorize it like this. But that's still not enough because alpha plus beta is good. We can replace with the 3/2. But the alpha square minus alpha beta plus beta square, not so easy. You need to realize there's a special identity. It's just alpha plus beta bracket square, but you minus away 3 copies of alpha beta. Can you see why it's true?
Because
just expand.
Yeah, okay.
Let's see what happens if you expand. This guy a plus b bracket square. So a square plus 2ab plus b square. Then minus away 3 copies of alpha beta. Plus 2 minus 3, what happens? -1. So that's why they are the same. Is it clear? Okay, so this is a very special identity. You just need to know the trick. It's just like trigo identities. Okay, a bit difficult. That's why it was removed from the syllabus. Okay, so alpha plus beta bracket square minus 3 times alpha beta. Hey, just nice. Got a plus here, got a product here. You can just substitute with whatever you found out. Can you see? Then just the rest is just substitution. I'm sure you know what to do. And you eventually get 9/8. But for the next one, product of roots, you need to remember the formula. You still need product of roots here. So that's why you proceed to multiply the two roots, which is alpha cube and beta cube. Again, there was a typo in the question 8 part 2. It should have been a beta cube, not b cube. Find the quadratic equation whose roots are alpha cube and beta cube. So that's why it's multiply alpha cube with beta cube. You can factor out the cube, so it becomes alpha beta bracket power 3. And we know what's alpha beta, right? It's over here, half. So half cube, and you get 1/8. Then you just sub in the formula, minus away sum of roots times x plus product of roots with a 1x square at the front equals 0. That's your answer. You could also multiply throughout by 8. You get 8x squared minus 9x plus 1. Equivalent. Both are acceptable. Is that okay? Okay, yeah. So moving on. Oh, right. Sorry, one more point to bring up is here you found the roots. One of them is alpha, one of them is beta. But actually, this question is trying to test you on with how to solve this question without solving for the roots explicitly. So you don't need to know that one of them is half and one of them is 1 directly. You're supposed to use this information here, which is what you have done. Huh? Okay, then. Yeah, also what you're doing here, the procedure to find alpha plus beta first and alpha beta is the correct way to do it. Moving on. What else went wrong? Here what is it? For question 10 part 4, is it? The equation of the circle reflected about the line y equal to x. So your original circle is this fella. The center is 5, 10. I hope that this picture can convince you that the moment you reflect something about y equal to x, the x and the y will swap around. Can you see that? So that means that the center of the circle 5, 10 will also become 10, 5 after reflection. Okay? But all the other points will also have their x and y swap around, but that's not important because in order to get the equation of the new circle, all we need is the new center and the new radius. New radius in apostrophe. So can you tell me what happens to the radius after you reflect?
Same.
Stays the same. But the center, does it stay the same as well?
No.
No. You have to swap x and y around. Okay, so now, therefore, I hope this picture is convincing enough. Original circle 5, 10 center, reflect becomes 10, 5. So our center is currently what? New center is 10, 5. How about the new radius? It didn't change. So it's still, what was the radius again? Can't remember. What was the radius? The radius was a square root 2, I think. Yeah. Okay. Then with that information, you're able to just get the equation of the circle, which I've written down over here already. Okay. Yeah, that's all. Reflection, just a special trick. This one just a note on presentation. You can write it more efficiently by just simply saying g of half equals 0. Don't need to write in 2 separate lines.
G of half equals 0. Okay.
Don't need to write g of x again. You're simply replacing the x with a half. Okay. Okay. The rest are all correct. Yeah, nothing to say. Good. We're done.
Wait, can I ask
sorry. Yes.
question?
Yes, please.
It's gonna be very stupid.
Carry on.
You know, like the first question for paper 2.
Yes.
Wait. How? Okay, so like I completely forgot how to do it, so I had to look back at the old I don't know, like
Notes.
yeah. Then like, what's the point of this drawing? Like I actually don't know. Like
a point of this drawing, it's basically drawing out the. Okay, here is how I interpret the quadratic inequality. 4x minus 9 times x minus 1 more than 0. Here it's really just a y1. There is a y2.
Yeah.
Right. So this is just a simple sketch of the x and y axis. I avoided drawing the x and y axis. Here's a root 1. Here's a root 2.25, and then there's a happy face.
Yeah.
This is y1 equals 4x minus 9 times x minus 1. That's your y1. Like just like your trigo sketching kind of questions when you want to figure out which graph is above, which graph is below, right? here we got y1 and y2. You want y1 above y2. y2
Oh,
being
okay.
y2 equals 0, which is the x-axis.
Oh, so it's like.
So you
Oh,
want the
so
part of
that's
the
how.
graph.
That's how you know this.
Yeah, exactly.
Oh, okay. Okay.
Yeah.
Okay.
Then you want the corresponding shadow that has the part of the y1 graph above y2. Yeah.
Yeah. Cool. Cool. Cool.
Okay, if you understand this, you're ready for H2 math already. You can do inequalities topic in H2. All right. But yeah, you'll just need to in the future, the graph will just get crazier and crazier. They'll just give you like 4x cubed over x squared times x minus 1 more than 5 sine x. Okay, then they'll ask you find the corresponding solution to this. In the future, you will have access to software. You can just type it in the calculator. Y equal this guy, y equal that guy. This is y1, that is y2. You just want to find the corresponding x values such that the y1 graph is above y2. Same idea. Can understand?
Yeah.
Okay. So that's irrelevant, and we are finally done with Swiss Cottage. Okay, yay. Let's move on to Trigo. So the questions I marked, I think most of them were correct, right? Was there anything wrong? Is there anything? Oh yeah. Have you tried the question 26, question 27?
Question 26, question
the-
27.
From the very first worksheet. The HW Trigo proof questions, question 19 to question 24 and 26 to 27. I think. Did I not assign that? I didn't assign that. Okay. But 19 to 24,
Yeah, I send you.
I sent already.
Wait,
Oh,
really?
Yes, I already marked it. I mean, I just read through it, and most of them are correct except for the question 24. Actually, it's also correct. I just need to give a bit of reason. Yeah. Okay. So you didn't try 25 and 26, is it? I mean, 25 went through already. 26 and 27. Haven't tried it.
No.
Okay. Okay. Then in that case, I'll just go through it. Wait a minute. Where was that worksheet again? Okay. Proving identities. Okay, give me a second. Let me just name the file. Trigo homework. Question 25, 26. Okay, let me find the correct file first. Oh, it's not 25, 26, it's 26 and 7. 26 and 27. Okay, let me just label this. Okay, let's go through question 26. So what we have here, we have tangent of A plus the sine of A equals to P. And what else we have? We have tangent of A minus the sine of A equals to Q. Can you see a pattern here? Can you see a pattern? Plus and minus, right? So that means that we can try to get rid of things by doing a bit of simultaneous equations. Similar to the what do you call it? The product of sum formula that I went through just now. So our objective here, let's just write it down first. Our goal is to prove that p squared minus q squared equals to 4 times of the square root pq. So I realized that both sides are a bit difficult to deal with. So I will just deal with it piece by piece. I'll make sure they meet in the middle. Let's figure out the left-hand side first. LHS, which is p squared minus q squared. If you see square minus square, hopefully you can immediately know it's p minus q times p plus q. And then you can recognize, it's just taking equation 1 plus equation 2 and equation 1 minus equation 2. respectively. Maybe I'll just do it at the side. I take 1 plus 2. What do I get? 10A, 10A plus sine A plus 10A minus sine A, right? On the left hand side, which is 210A. I'll write it on the left hand side of the equation. But on the right hand side, P and Q.
P plus
just,
Q.
Exactly. So therefore, we have obtained our P plus Q is just 210A, substitute. But what about if I take 1, I want P minus Q now, so what should I do? 1.
1 minus 2.
Very good, exactly. 1 minus 2. Okay, so we'll do that as well. So tangent A, I'm just gonna
2 sine A.
Yes, correct. Very good. Just have to change it to a minus bracket, and the P plus Q change to a P minus Q. And it is just 2 sine A equals P minus Q. So we can just sub in 2 sine A. Okay, then we can multiply it. 2 times 2 is 4 sine A times 10A. I will leave it alone. And then I'm confused. I'm stuck. What do I do when I'm stuck? I stop here and then I proceed to
the other side.
Hand side, exactly. So we'll go to the right hand side now, which is 4 times square root PQ. 4 times square root of what's P times Q? You just sub in the P, 10A plus sine A, sub in the Q, 10A minus sine A. Don't forget the square root. So I hope you notice a pattern A plus B times A minus B. Can you see?
Yeah.
A plus B, A minus B. So you can straight away factorize it as tangent square A minus sine square A. Is this step clear to you?
Mm-hmm.
Can? Okay, very good. Then how do I proceed? How do I show that I'll get sine A tangent A from a, how do I link it to a square root? Can you just immediately cancel off with the square root of the square?
Wait, say again.
Can you split out like this, the square roots? So you get 3 minus 4. So square root 3 square minus 4 square is 3 minus 4. Is this true?
No.
Definitely not true. Because there is a minus here, 2 separate terms, you are not allowed. This is not true.
Yeah.
Anyways, this is not even illegal. This is imaginary numbers already. 3 square minus 4 square. You get negative something. But anyways, so what do we need to do now is to make sure that the square root disappears, which means that underneath the square root, what we call the radicand. This entire thing is called the radicand. The thing that's the entire thing underneath the square root, it has to contain a square. You need to rewrite it as blah to the power of 2. Or some even power, power 4, power 6. So we can cancel off with the square root. Right? Square root is just power half. Because at the original sine A, 10A, there is no square root involved. Here, we have a square root. So in order to make them the same, it means naturally that I need to get rid of the square root, which means that my radicand, I need it in the form of something power 2 or power 4.
How?
How? That's when you have to look at the square and then you think, trigo identities.
Well,
Got square. So what should we use? Let's look at the identities and see which one is relevant. Let me find the correct identities page and I'll just copy and paste it. Copy and paste it here. Okay, which one can we use? Let's think about it.
which one can we use?
Eventually, we need to show it's sine A, 10A.
Eventually, we need to show sine A, 10E. Or I mean, for the sine. Wait, how? Wait, what? Yeah, how?
Okay. When I see tangent square, I'm thinking maybe I can replace with secant square minus 8, secant square minus 1. When I see sine square, I'm thinking maybe I can replace with 1 minus cos square. But then after thinking a bit more, maybe that's not such a good idea. Because we need sine A, tangent A. If you do a few steps ahead, I think we'll just get stuck because we're going to be introducing secant square here and cosine square, which is going further away from what we want, right? We actually want sine and tangent product. So how about, let's do another trick. Whenever you're stuck, you always convert everything back into sines and cosines, right? Let's just do that. Maybe I cannot see so far ahead.
Okay.
I'm just going to replace everything with sine and cosine. So 4 sine A times tangent A is what? I'm starting from the left-hand side. Everything down into sines and cosines. Then this is actually just 4 sine square A at the top and cosine A at the bottom. So that means we need our square root whatever to be the same as sine square over cos A. Which means that underneath the square root, right, it must actually be this guy squared. Can you see that?
Okay.
So that's our objective now, to show that these two are the same. But if you square this, this is really just sine power 4 over cosine squared.
Okay.
So that means we need these two to be the same. We need to show that the tangent square A minus sine square A eventually becomes a fraction, sine power 4 over cosine square. How can we introduce a fraction?
Change the tangent square to sine square over cosine square.
Exactly. But don't forget the 4 times square root. Let me just write it neatly. 4. Okay, yeah, so sine square A over cosine square A minus sine square A. Can I just skip a step? I'm just going to multiply top and bottom by cosine square first. Right? And then 4 times square root of combined into a single fraction, you get sine square A minus sine square A times the cosine square A. All divided by cosine square A. Whole thing square root. Right? Yeah? Can Are we getting closer? Hopefully. Let's just see. Let's just continue and see. What do we need? We need just a single numerator, right? Sorry, a single term in the numerator, right? But here you see how many terms? There's a single minus sign, so how many terms in the numerator?
1.
No, 2. How do you distinguish term? I'm asking in this fraction here, in this fraction here, the numerator, how many terms? In the numerator of this fraction.
In the numerator, 2.
2 terms. Okay. Here and there, right? But look at the numerator of the fraction over there. Here.
Okay. Only 1.
Only 1.
Get rid of the cosine thingy.
How?
Sub in
Can I sub in? Maybe there's a more strategic way. You see sine square A here, you see sine square A there.
Factor sine square A.
Much faster. Very good. Then you can get 1 minus cosine square A. Then what happens?
You get tangent.
Wait.
The
tangent gotta go back.
This thing becomes the 1 minus cosine square A becomes sine square A. Of course.
Good. Yes. Just show the step-by-step procedure. Sine square A, then the 1 minus cos square becomes sine square A. Over cosine square A.
You get sine to the power of 4. Sine to the power of 4A over cosine square A, which is like this. Wait, no. Then you have your square root thingy, which is like just sine square A over cosine A. And then
you can split the square root up, right?
Yeah.
And then yes, eventually it will be 4 sine square A over cos A. Done. Same as the expression at the top. Here and here. Okay? Show the working step by step. Right? Square root of a fraction means square root at the top, square root at the bottom. Then square root of a power 4 means power half. Half times 4 is 2. Half times 2 is just 1. Power 1 don't need to write. And then we are done. Okay? Can also just meet in the middle. Meet in the middle. That's the most powerful trick. And what else? What other tricks you need? You need to split everything up into sines and cosines. maybe you can do an experiment on your own, whether using the tangent square equals to secant square minus 1, would that help in solving the question? I cannot see it immediately. Maybe it works. I'm not sure. You can go and do it on your own. Okay? Can Yeah, that is question 26. Let me see if I finish the question. Yeah, question 26 is done. Moving on to question 27. Question 27 asks, tells you first, sine x equals to m plus n. Cosine x equals to m minus n. Now in part 1, you want to show that m square minus n square is half sine 2x. Remember, this is a show question. You're not trying to solve yet. So how do you proceed? M square minus n square is what? How to factorize? Okay, what's given?
Okay.
What is m square minus n square?
And I mean, it's just sine x times cosine x.
Yes, correct. Yes, it's m plus n times m minus n, which is sine x times cosine x. Then how?
Then how? Or
Okay, I guess is it obvious now?
I mean, wait, what? What do you mean?
You're trying to show this, right? The right hand side is now half sine 2x.
Yeah.
Is it
Yeah.
obvious to you now? Okay, maybe
What's obvious? Wait,
the-
what do you mean?
I'm going to skip to the last line already. Is it okay?
Like,
with
yeah, I mean, sine 2a equal to sine a cos a.
correct?
Then divide by 2. Is this what you're talking about?
Yes, correct.
Okay. Yeah.
Okay, you got it. Yep. Alternatively, you could also times 2 and times half if you want. Like what I mean is a bit long-winded, not really needed. But you can also do the following: times 2 in front, and then you times half in front. And then you realize, 2 sine x cos x is the same as sine 2x, but with a half in front. That could also work. Yeah, and then eventually it's RHS and you're done. Ding. Okay, moving on, part 2. Part 2 asks, find the numerical value of m squared. This time it's not minus, it's a plus n squared. Now we have already just went through the sum and product, the sum of roots, product of roots idea, right? Can you come up with a special identity for this to solve?
Special identity.
Mm-hmm. Oh, wait. Oh, I went through this last week. Can remember the hint I gave.
What do you mean?
I gave a hint last week. I forgot to assign as homework in the message, but I already gave the hint. Do you recall this?
No.
No. I didn't send you this file. Did I not send you this file? Okay, wait, hold on. Let me just send this file. Let me just send this file in case I forget. In case I have forgotten. Okay, sending now. I need to come up with a better way of naming the files. I think that's why it's a bit confusing. Proving identity 7-10 marked Brandon. That worksheet, that PDF. Can? So what did I tell you? We started off by figuring out some prerequisite identities, right? Like the ingredients that you'll need for this recipe.
Okay.
What were they? Tell me the ingredients. This is the event recipe.
M square plus n square equals to m plus n square minus 2m.
Bracket square, you mean? Minus 2. Okay, can? Then what's m plus n? Oh, sorry, I forgot to share screen. Right. Sorry. Yes, you are saying this. I'm writing down. Then what's n plus n here inside the bracket?
M plus N is sine X.
Okay, so sine x bracket square minus 2mn. What's mn?
I mean you just change it to
Change what? Maybe I'll call this equation 1 and I'll call this equation 2. Can you tell me what do I do to find mn? Maybe over here.
you do
Or maybe you tell me how to find m first. Then later we find n individually. Later then we combine together.
M is 1 minus 2.
Huh? How do you get that?
Wait. I mean
Oh, sorry.
One,
Right, yes.
M is 1 plus 2 divided by
Equation
2.
1 plus 2. Okay. I thought 1 plus 2, 3. 1 plus 2 is 3. What? Okay, sorry.
By 2.
Then you need to divide by 2. Very good. Yes. So let's just work it out slowly. So sine x plus cosine x, then whole thing divided by 2 equals to m plus n minus n divided by 2. Sorry for the handwriting. Anything to cancel? Yes, the plus n minus n cancels away. You're left with 2m divided by 2, which is just m. Doesn't this remind you of the factor product, the product to some formula procedure that I just talked about? Hopefully it does. Okay. Then after that, how to find n?
1 minus 2 divided by 2.
Okay. Of course, it's the symmetrical one. Just change the plus sign to a minus. Let's just write it down for us. Let me show you the equation 1 and 2. Sine x minus cosine x whole thing divided by 2 equals to m plus n bracket minus away m minus n bracket. Actually, the first pair of brackets is not needed. So I'll just erase it. Then whole thing divided by 2. Open up the bracket with the minus. Bring the minus inside the bracket. So minus n plus n all divided by 2. Clear so far? Okay. Then minus m and plus m, they cancel each other off. The green color highlight. N plus n gives you 2n. Divided by 2 is just a single n. All right, very good. We found our identity for m and n. So now we can just sub in now. So here we got sine square x minus away 2 times m, which is sine x plus cosine x all divided by 2 times the n, which is sine x minus cos x all divided by 2. Is that okay? Anything to cancel? Yes, the 2 and 2 cancel away. But what is so special about this guy times that guy? Maybe we take it step by step first. I also need more space. Please give me some time to rearrange my working. Okay, we can ignore the rest already. Just focus on this. Yeah. Okay, like this. Clean up a bit, So sine square x minus away. There's a fraction here. We got sine x plus cosine x as the numerator of the first fraction. Bracket, multiply by the numerator of the second fraction. Sine x minus cos x. Carry on. What should you
do? Expand.
Expand. Can you see any special formula here? Special pattern?
Special pattern. A plus B, A minus P equal to A square minus B square equal to sine square minus cosine square x.
Very good. All over 2.
Then I mean you can sub in the sine square x with 1 minus cosine. Wait, no. You can sub in the cosine square with equals sine 1 minus sine square x.
Good choice, because you see a sine square here, right? So you want everything to be sine square. Okay. So, oh wait, sorry, you are wait. You're talking about this guy, right? Cosine square, change it to 1
Yeah,
sine.
yeah.
Okay, you see how to think about it is odd one out. There's sine square, there's sine square, there's cos square. Who's the odd one out?
Cos.
Cos square. So that's why you want to change it, become all homogeneous, all the same type. Sine square, then the last one is cosine square, change it into the same, so that it's easier to deal with. Yeah, so then cosine square replaced with 1 minus sine square with a minus sign. I'm just gonna skip a step. I bring the minus in, so become minus 1 plus sine square. Is that okay? Not too confusing. Okay, then what happens? You're left with 2 sine square minus 1, right? All over 2, and with a minus, and then there's a sine square. How to continue? You want the value, so this is not good enough. How about if we just split this fraction up? So we can do the following. 2 sine square x over 2 minus away 1 over 2. Is that okay? Same, right? 2p minus 1 over 2 is the same as 2p over 2 minus 1 over 2. Same idea, just p being the sine square. But what is so useful about this is 2 over 2. What happens? Cancel off. Okay? 1 over 2, can we cancel? Cannot. Leave it alone.
Yep.
Simplify, and what do we get?
You get half.
Minus. No, yes, exactly, just half. Right. Okay, let me just do it step by step first. 2 cancel away, so you're left with sine square minus half. Minus outside the bracket, bring in. Then it's just sine square x minus sine square x plus half. What cancels? Sine square cancels. You're left with just a half. Ding ding. The numerical value. Okay? Can? Yeah. You don't find this amazing? You see, you start off with what? Sine x and cosine x. Then at the end of the day, this expression, suddenly no more sine, no more cosine, just a number. Isn't it weird? No?
No.
No? Oh, okay. Wow. Okay, maybe you're very familiar with math already. Because I find that when I first saw this, I was very confused. I was totally confused. Why suddenly we were talking about trigo, then suddenly it becomes just
Okay, yeah, I mean, it's weird.
So weird. All right. Okay, so yeah, that is the end of this worksheet. And moving on to your homework. I already looked through most of them, right? I mean, all of them. Most of them are just correct. So nothing to talk about. In that case, actually, there's the question that you said some of them are quite different, you cannot solve, right?
Some of them are quite different. The textbook one.
Yeah, correct.
You made a video to like explain how to do the question. Then I could do the question, but then the question after that was like a bit different.
X and Y. Yeah. Okay. I realized it's quite different. But the techniques are roughly the same. Okay.
Okay.
Except question 13, I think. 13 is a bit challenging. The red color one. The red color questions in the textbook are always super challenging, but still doable. Let me just do something first. Let me rename the file first. Okay, and then I'll just do something. Give me a second. Oh. What was the exercise again? Exercise 9. 9 what again? 9C. Okay. Let's see. You got the textbook with you?
Yeah. Wait. Yeah, I do. Yeah.
Okay. Okay, let's go to question exercise. Exercise 9C question. What's the number again? Exercise 9C question 5 went through already. Question 9 we go through together. Okay, So for question 9, they gave you, what is it, sine of A minus B equals to 16 over 65. What else did they give you? They also give you sine A cos B equals to 36 over 65. Now, the objective of this question is not to find angle A and angle B explicitly. Just like the sum of roots, product of roots question. You don't want to find the angle directly. It's a bit difficult. Okay. And also in this question, you don't really need to find, what do you call it? The alpha, right? The basic angle of it. Oh. Then you go and sub in. You also don't try to find explicitly what is A minus B. Okay, the angle over there. Instead, you use identities. Okay, can So let's take a look. What is so special about? Actually, you know what? Let me just write down the question further. These are the given information, and let me just at least write down part 1. The objective here is to find cos A sine B. Now, since we're using identities here, wouldn't it make sense if we just copy down the identity first, or just have it for reference at the side? So that's exactly what I proceed to do. You should also do the same when you're doing the question. Put the formula at the side somewhere. Okay. Then think about it. Cosine A sine B, sine A minus B, sine A cos B. Look through the formula. Which one is relevant? Which one is relevant?
Sine A minus B.
This expansion here, right?
Yeah.
That one is relevant. This guy. Oh, sorry. This guy is relevant, right? So that's what we're going to do. We're gonna expand out sine A minus B. Just copy down the formula. Can you tell me what is it? Sine A minus. Expand formula.
B equals to sine A cosine B minus cosine A sine B.
Very good. Anything we can substitute?
Substitute.
We're given these two.
Sine A cosine B is 36 over 65. Oh wait, no.
Then?
Yeah, no, I mean, 16. Oh, what the hell? 16 over 65. And then you just you bring over, then you 36 minus 20 over 65. 20 over 65.
Then you just simplify, and that's your answer. Yes, correct. As simple as that. Yeah.
Huh? Is that
That's
simple?
Yes.
What the hell?
You just need to use the formula, okay? So this one, don't need to find the angle, don't need to find the any of the specific alpha or A minus B, just use formula, okay?
Wow.
Yeah. So
I feel like I was tricked.
like
Like the previous one was so hard, and it was just to like, I don't know. I mean, it's not hard. It's just like a long process.
Yes. Yeah. Okay. So anyways, you know how to find part 1. How about part 2 now? Part 2 asks you to find sine A plus B this time. Remind me again, is this the same as sine A plus sine B? Are they equal?
No.
Definitely not. Very good. So what is it equal to?
Sine A plus B equals to sine A cosine B plus cosine A sine B.
Sine cos B plus cos A sine B. Sine A cos B plus cos A sine B. Maybe you can memorize it. I don't know. Don't need, but you will go faster if you memorize. And anyways, you got this. Then how? Or at least recognize that you should be expanding it out the moment you see this A plus B inside. Then?
Then you can sub in sine A cosine B and
with what?
36 over 65. And then I just realized you can sub in cosine A sine B. with 4/13.
Exactly. And then you're done. Just key in the calculator.
56/65.
Okay. Yeah, good. That is part 2 done. Part 3, let's go. Part 3 asks to find 3 tangent A. Question 9. 3 tangent A cotangent B. How? You see what's given, all sines and cosines. Suddenly got tangent. What do you do?
Change tangent to sine A over cosine B. Change cotangent equals to 1. Change cotangent equals to cosine B over sine A.
Wait. Cosine B over sine A?
Cosine B over sine, you know what I mean.
No, I don't understand. Say again. Say it correctly. Cotangent B is equal
Like
to?
that. Oh wait, no, I wrote. Oh wait. It's just both B.
Must both be the same angle, must remember this.
Yeah.
Okay, yeah. So anyways, cosine B over sine. Yeah. Okay, I'm just substituting step by step. Tangent A is sine A over cosine A. Cotangent B is the reciprocal, so cosine B over sine B. Very good. So angle must make sure they are the same. Very important. Then how? Let's look at what we have.
Sub.
What? Yeah, it's just purple. Blue. Can see?
Yep.
Exactly. Just sub in, right? Okay. Then I'll leave you to figure out the answer. Dot. Yes, you did it correctly. Just 3 times 36/65, all divide by the purple one, 56/65. You can go figure out yourself. The technique is more important. The answer not so important. Is that okay? All right, just substitute. I'm sure you understand what the blue and purple highlight means. Moving on to the next question. Question 9 is done. Question 12. Wow, question 12. Oh my. Question 12. You see what? It's exactly the same as the question I went through in the answer in the video, but it's just that instead of numbers, we give you letters. So sine A equal to X, cosine B equals to Y. They didn't give you a number, they give you an X, give you a Y. And they also tell you that A is an angle that's in between 90 and 180 degrees. B is an angle in between 270 and 360. So of course it must be what quadrant? Let's see, Q1, Q2, Q3, Q4. Angle A is more than 90, less than 180. So that's angle A. And quadrant 4 must be angle B, right? Yes? Very good. So what do we know about ASTC? So angle A is in quadrant 2, S also quadrant 2. So that means sine of angle A is plus or minus. Sine of angle A is a positive or negative value?
Positive.
Positive. So that means that X is more than 0. Let's just keep that in mind. How about Y? Cosine B. B is an angle in quadrant 4. Y is more than 0. Exactly. Okay, just keep that in mind. So that means that the corresponding sine of the alpha associated with angle A will also be equal to X. The cosine of the alpha associated with angle B will also be equals to Y. But knowing the alpha is not that important and it makes things quite complicated, so I'm just going to strike it out. Even though it's true, not relevant. We don't talk about it. So now let's figure out how to solve this question. The part 1, they ask us to find sine A plus B. What should you do the moment you see A plus B inside the angle?
Identity.
I'll just copy and paste it down for you. So like this, yeah, equals to, exactly, yes. Remember for sine is the same direction. Same sign. What do I mean? Same SINE is the same SIGN. Plus with plus. Minus with minus. Anything we can replace now?
XY plus. Yeah, I don't know.
Then we'll start. What should we do? Then that's when you need to draw right angles. Right? Remember the 3-step procedure? Now it's step
Okay.
2, draw right angle. So maybe I'll draw it at the side. How? I want to save some space. Let me bring it down. Okay, I'll draw it at the corner here. I like to draw a quadrant 1 angle like this. So there's an angle A and there's another angle B. Sine is x. So it's really just opposite over hypotenuse 1. X is the same as x over 1, right? Over 1, over 1. Likewise, for cosine, it will be y over 1, so adjacent over hypotenuse. Then the remaining length here, what would it be in terms of x? Pythagoras theorem tells you it's square root of 1 minus x squared, right? Is that okay?
Yeah.
Long square minus short square. Then likewise for the other guy, it's 1 square, which is just 1, minus away y squared. Take a square. Okay, can very good. So what is cosine A now? What is sine B? Yes, square root 1 minus x squared is cosine A. How about sine B? Square root 1 minus y squared. Yes. They didn't ask for everything in terms of x or y, right? So this is the answer already. In terms of x, n slash or y, that's the answer. But then actually we have to be careful a bit. Here, cosine A, A is what angle? In quadrant 2. Right? So only sine is positive. So that means that this cosine A here,
Negative.
you cannot just take value. You need a negative, right? Technically, right? So we should put down a minus sign here. Bracket around cosine A. How about sine B? Same thing, same story. Angle B here is in quadrant 4. So cosine only positive, so sine must be negative. So that's why you need another negative here. So coincidentally, the minus cancels away. So the original answer was still correct. But this is the proper way to do it, okay? There's the minus that appears 2 times. That's why at the end of the day, no more minus. Is that okay? Okay, good. Moving on to part 2. What's part 2 asking? Cosine A minus B this time. So formula, tell me. Read for me.
Cosine A minus B equals to cosine A cosine B plus sine A sine B.
Very good. Now, maybe it will be easier if we just list out all the sine A and cosine A at the side first. Okay, let's just do that. So sine A equals to x. How about cosine A? Cosine A is negative of square root 1 minus x squared. The negative is because it's in quadrant 2. Then how about the, I need to save some space. Let me shrink the formula down a bit. Sine B is, what is it? Square root 1 minus y squared over 1, but you have an extra minus in front, and cosine B is whatever was given, y. Tangent B, tangent A, we'll find it if we need to later. I'll leave some space here. Now just substitute in, so cosine A is negative square root 1 minus x squared. Bracket. Cosine B is y. Plus sine A is x. Sine B is negative 1 square root 1 minus y squared. Okay? That's your answer already. I mean, if you want, you can simplify a negative y and negative x, but that's the answer already. Done. Okay? Can?
Okay.
And now moving on to part 3. Where is part 3? Tangent 2A. What do you think you want to do now? Tangent 2A.
So 2 tangent A over 1 minus tangent square A.
Yeah, exactly. But we need tangent A only, right? We just need tangent A, right? So that's why the blank space here, now you have to fill in the blank. What's tangent of A?
Tangent A equals x over square root 1 minus x squared and negative.
Very good. Yes, because angle A is in quadrant 2. Only which is positive, only S sign is positive. So tangent must be negative. Okay, very good. Then just sub in. Do I need to do it? Or can you do it on your own? got square root. Maybe I'll just demonstrate. Huh? Okay, 2 times tangent A, so 2 times negative x over square root 1 minus x squared, all divided by 1 minus tangent square A. So we're going to take the entire thing, copy and paste it over bracket power 2. Now, when you have negative square, it's really the same as like negative 2 bracket square. It's negative 1 times 2, right? So it's negative 1 times 2 square. So you'll end up with a positive 1 then 2 square. So essentially the minus disappears. Here we can also do the same thing, but with algebra. So the minus just disappears. And that means we can erase the negative sign there. Okay, then the square, you can bring it into the numerator and denominator. So you end up with what? I'm just going to skip a few steps. This becomes x squared at the top and square at the bottom. Square or square root, what happens? What happens when you square or square root?
Cancel.
They cancel away. Exactly. So that means that this and that will cancel away. Then this guy you can multiply in. So it becomes a negative 2x at the numerator. Then now we need to continue simplifying this fraction. Let's just continue. So this guy, how should we continue? This is a good practice actually, because the few chapters later we will learn about differentiation. You will need to get used to seeing square roots in the denominator or some complicated expression in the denominator. But let me just get rid of this square root and square first. I see something minus something. I will want to combine them first. I think it's easier. Okay, I think it's easier. So let's just simplify it down. Minus 2x over square root 1 minus x squared, all divided by, here is 1 minus x squared all over 1 minus x squared, right? Very good. So this guy is really just 1 minus 2x squared, right? So we can just replace the numerator with 1 minus 2x squared. Right? Then this is fraction. This is fraction at the top divided by fraction at the bottom. If you recall, it's just this guy, the numerator, divide by denominator. So you multiply by the reciprocal, right? Keep change and flip. So it's 1 minus x squared times on the top and 1 minus 2x squared at the bottom. Is this okay? Okay now? Very good. You can simplify a bit more. What do you notice about square root 1 minus x squared and 1 minus x squared? Anything to cancel? Can you see? Let me write it more explicitly for you. Square root is the same as power half. Here there's an invisible power 1.
Can't cancel.
You can. Whenever the base is the same inside the bracket. I know it looks a bit weird. 1 minus x squared got 2 terms inside. But it's still the same, right? Can you see? Inside the bracket, it looks exactly the same. So whenever the base is the same and you're multiplying factors and the power is different, you can just recall the rule. A over B divided by A over, usually it's M. M and N. It's just equals to A to the power of M minus N. It's just that in this case, M and A power M and A power N looks a bit funny. It's like separated by some fraction. Right? The A power N in this case is 1 minus x squared power half. The A power M in this case is 1 minus x squared power 1. Right? Yeah, that's why you can still combine them. So what I'm trying to say here is this and this will cancel off, half power and 1 power. You bring this half power on top, so it becomes a 1 minus half. At the end of the day, you will obtain the following. This is a good practice. You need to get used to dealing with this kind of expressions. So this becomes a 1. That becomes a 1 minus half, which is just a half. Yeah, which is, of course, what is power half? Power half is really just a square root. So we can write it as a square root of 1 minus x squared, the numerator. So we sort of rationalize the denominator. Can you see that? Go from this step to this step is very important. Important. Okay, then can we cancel off 1 with 1 and x squared with x squared like that? Here, fraction ma. You see on top and bottom same, then cancel. Is it true? You see the same, then just cancel. True or false?
What do you mean?
Can I do this? This fraction is exactly the same as I cancel off the 1, I cancel off the x squared, so I'm left with a 0, then cancel off, I'm left with a -2 like this.
No.
No? Why no?
Wait, why yes?
It's no, it's cannot. I'm just trying to trick you. Okay. What is the rule? You can only cancel off what? Common what?
Common base.
No, common factor.
Mhm.
Factor. Right? Like 12 over 18. You can factor out of 2, so 2 times 6. Factor out of 2, 2 times 9. The factor means you're multiplying by that number that's the same, then you can cancel away.
Mhm.
Okay, that's multiplying by common factor. Please remember this idea. I don't want you to go and see 1 same, then you cancel away. X and X same, then you go and cancel away. No such thing. Okay, because it's protected by a square root. When it's protected by a square root, it's like one entire expression on its own. Okay, very good. We just erase the nonsense away, and that's your answer already, essentially. If you want, you can clean up a bit more. So minus 2x times 1 minus x squared, square root, all divided by 1 minus 2x squared. Answer. Okay?
Okay.
Oh, one more trick question. Can you cancel off this x with the x squared here? One copy like that?
No.
Why cannot? Is it? Yeah, you're correct. It's not allowed. But do you know the reason?
I mean,
Only
I
can
can
cancel off common
factor.
factor. Here, this x squared is a single term. 1 is another separate term. So x at the bottom here is not a factor. Okay, so we cannot cancel off. Right? This x here is a factor. There's a -2 times a x times a square root something. So they are 3 separate factors. Here is 2 separate terms. Okay. I'm not gonna write it down because not so important. Just make sure you do the correct simplification. Can? Okay, that is the answer for part 3, tangent 2a. Then you proceed with part 4 and part 5. It's just spamming with all the double angles of sine 2b, cosine 2b. And they change it up to angle b. So let's proceed. Part 4, sine of 2b. Now recall the things we have covered so far. We have discovered so far. I mean, we got sine A, cos A, tangent A, we got sine B, cosine B. Now we are trying to expand sine 2b. Which formula do you think you should use? How many options are there? Sine 2b.
1 sine 2b equals to 2 sine b cosine b.
Exactly. So let's just write it down here since formulas are all available. 2 sine b cosine b will be equal to 2 times
Sine b cosine.
Correct. Over here written down already. What's sine b?
Sine b is square root 1 minus y square. Cosine b is
Please be careful, there's a minus in front. Okay, there's a minus in front here. Remember? Do you understand why there's a minus?
because it's not in the quadrant. I mean, it's in the fourth quadrant.
Where only cosine is positive, sine is negative. That's why you need a minus. And we know this value here, square root 1 minus y squared, is positive because we know y is positive. Actually, in general, square root is always positive. Okay, yeah, so basically there's a minus. There should be a minus. How about cosine b? Nah, right there. Why? So just sub in. Okay, then that's your answer. You can clean it up a bit. So let me just show you how to clean it up. Sine 2b is 2 sine b cos b equals to 2 times square root negative square root 1 minus y squared times y. So it's negative 2y multiplied square root 1 minus y squared. Okay? Can? Good. Part 5. Now part 5 asks you to find cosine 2b. How many options for cosine 2b?
1.
One only?
I mean 3.
3. Must remember, sine double angle got 1 option. Tangent also only one option. Then for cosine got 3 options, the special one. So which option would you like? Set mu A, set mu B, or set mu C? Option 1, 2, or 3?
C.
Okay, actually all 3 can work because we have all the information we need already. So let's just use number 3. So 1 minus 2 sine
I
square.
guess two would be the easiest.
Oh, why then? No difference, no difference actually.
Won't it just be like very fast to do? 2y squared minus 1.
2y square. Yes, you're correct actually. 2 cosine square b minus 1, which is 2y square minus 1. Yes, actually. Yes. Yeah, then that's the answer. Okay, maybe just since we are already here, let's just verify that the other formula also works. 1 minus 2 sine square. 1 minus 2 sine square b is just 1 minus 2 multiplied by sine square in this case. You're taking this sine, you square it. This sine, you square it. Square a negative, the negative disappears. Square the square root also disappears. You're left with just 1 minus y square. Is that okay?
Mhm.
I was going a bit fast and I didn't write down the working. Can Then you just expand out, you realize it's 1 minus 2 plus 2y squared. 1 minus 2 is -1, 2y squared is just y squared. So therefore the answers are the same. So both formulas can work. You can verify on your own cos square a minus sine square a will also work. But I'll leave that as an exercise to you. Is that okay?
Mhm.
Yeah, then you get 2y squared minus 1. Let me just bring the working down. Bring the working down so it's neat and tidy. Like this. Somewhat. Okay, like this. Okay, then we are done with part V. Now we can move on to question 13. This is the most difficult one. Let's take a look at question 13 now. Question 13 asks us to, it gives us the following. Given cosine A plus B equals to 3/5. And then you have cos A cos B is, what is it? 7/10. Both A and B are acute angles. Is that relevant? I don't know. Find the value of tangent A, tangent B. How? You see what? All cosines, right? Here suddenly got tangent. So what do you think you should do as a first step?
Change to cosine.
But tangent A is not just cosine, it's 1 over cosine.
Sine over cosine.
Sine A over cosine A. Then the other guy, tangent B is? Tell me.
Cosine, I mean sine A. I mean sine B over cosine B.
The angle must be the same. B here, B here. A there, A there. Okay, so this simplifies into sine A, sine B over cos A, cos B. Is there something you can substitute now?
Mhm.
Top or bottom?
The bottom.
The bottom can be replaced directly with this fellow here, right? Let me just use a highlight blue color. It's just 7/10 at the bottom. But wait, why is sine A, sine B so difficult? How? That's when you have to look back at what's given. What have we not used yet? We used the blue one. Which one have we not used yet?
The left one.
This guy, cosine A plus B. So what do you think you want to do with the cosine A plus B? What do you do?
Cosine A plus B equals to.
Oh wait, I need to show you the formula. Sorry. Hold on a second.
Equals to sine A sine B. I mean equals to cosine A cosine B minus sine A sine B.
Yes, correct. Okay, let me just write down the notation like this. I'll draw a line, I'll draw open bracket, I put an asterisk here, close the bracket. And then I proceed to cos A plus B equals to whatever you said, cos A cos B minus sine A sine B. Sometimes when I'm lazy, I will just write down CA CB minus SA SB. Yeah. But okay, I'll try not to do that during lesson. Okay, I do that personally when I'm trying to do things fast. You can maybe do that as well if you're rushing for time. Okay, so anyways, it's equal to 3/5. But anything we can substitute inside this expanded version. You realize. Blue color again. Cos A, cos B, right?
Yep, sub 7/10. And you can find sine A, sine B. Then you can sub it.
Exactly. So let's just do that. Sine A, sine B in this case will be what? 7/10 minus 3/5. That's 1/10, right? Good. Then if it's 1/10, then we can say, let's just call this double star. Double star. Then I'll say sub double star, bracket, into single star. What do I get? I will get tangent A, tangent B on the left-hand side is equal to the right-hand side is sine A, sine B over 7/10, which is then equal to 1/10 divided by 7/10. Maybe I'll just write it slanted like this. 1/10 divided by 7/10 to save some space. End up the answer is 1/7. Is that okay? Okay, very, very good. Part 1 is done. Let's move on to part 2. Oh, where's my part 2? I lost the page. One tangent A minus B this time. How? Tangent A minus B. Okay, before I continue, let me just summarize. Let me just list down all the things we know so far. We know this guy, cos A plus B equals 3/5. We know cos A cos B equals to 7/10. We know that the we know that the sine A sine B is 1/10. Like this, sine A sine B is 1/10. We also know that tangent A tangent B is 1/7. Okay, this is a compilation of all the information we have gathered from the question so far. Then how? Tell me.
Change tangent A minus B equals to tangent A. Minus tangent A minus tangent B.
Wrong, plus. Hey, wait, let me see. Oh, you're correct. Sorry. Let me see again. Right, it's minus. I cannot remember. 10A minus 10B. Then all divided by?
1 plus tangent A tangent B.
Okay.
Sub in this with 1/7.
Good.
And then
numerator is 10A minus 10B. Good. Then what?
Tangent A. How? Sine A over cos A.
So now I hope you realize that it's getting a bit difficult, right?
Yeah.
Because you need to substitute with a fraction. So I'm gonna take a pause in the equation by writing down equation 1 like this. Neat and tidy, label the equation whenever you are not just directly substituting. And at the side, maybe you can draw a line like this. I don't know. Okay, I need more space. Definitely need more space. So I'm just going to bring down the necessary information here. So now our objective is to figure out what in the world is that numerator 10A minus 10B. So we work it out at the side, 10A minus 10B. Every time you have a break in the working, you just label an equation, then you draw a line, then you continue writing. So it's neat and tidy. Then you do what you are doing. Replace with the fraction, right? Sine A over cos A, minus away, what's tangent B? Every time you're stuck, replace everything with sine cosine.
B cosine B.
Over cosine B. Got fraction minus fraction, what do you think you want to do?
Fraction minus fraction, make same base, change the base to cosine A, cosine B, then the top becomes sine A, cosine B, minus sine B, E cosine A sub in sine wait, no, you cannot.
What were you thinking of substituting? Tell me.
I thought I could use this, but no, it's not the same.
Ah, very good. Very good. Yes, it's not the same. Yeah, you are thinking of using cos A plus B, right? Or maybe cos A cos B, right? But you realize none of them can be used. Sin A, sin B also cannot use.
Yeah.
Then how?
Yeah, then how?
That's why I say this question is difficult, right? Red color. How? Oh no. But there is one information that can be used, right? Blue color.
Yeah.
So still can. So not that bad, not entirely cannot use. Still can replace denominator with a 1 as a 7/10. But the numerator now becomes a problem. How? Think about it. All the information we have is available already. You just need to be strategic. In particular, this guy.
Okay.
What's that one trick we haven't done yet? You see, always just now, look at, if you recall, the sine A equal to X and cosine B equal to Y. What did we do just now?
I mean, we did what if? Wait, are you talking about the thing where it's like 1 plus 2 divided by 2? Like
Correct. Yes. Sorry, maybe I wasn't prompting it correctly. Yes, I'm trying to link you to say that. Yes. So now we're gonna take another pause here. Equation number 2, draw a line again. Then we're gonna focus on the numerator of this number 2. So I hope you can realize the value in doing this. If you squeeze everything, this entire monster inside the numerator here, it's gonna get very ugly very fast. Because now we're gonna do even more work on the numerator of the numerator of the numerator of the numerator. So yeah, draw a line and call it something else. We're gonna deal with the numerator. What are you doing? Okay, very good. Hey, don't erase. Yes, so let me copy down. Sin A plus B is equal to what again? Sin A cos B plus cos A sin B. Oh, I should show the formula, sorry. I need to figure out a way to show everything on the same page. Wait a second. This is very messy. Let me shrink it down. Drag it down. Rearrange. Bring on top. Bring back down.
Okay, I don't know how this helps.
Let me think a bit. How does this help again? If there was an A minus. Right. Okay. Pause a while and look carefully at the numerator sin A cos B minus cos A sin B. It looks exactly the same as one of the formulas. Which one?
It looks like the second one, sin A minus B.
Exactly, it is sin A minus B. So we can actually update this equation a bit. I'm running out of space. So this is exactly equals to sin A minus B all over 7/10. So our objective now is really to find out what is sin A minus B. Okay, then look carefully at what you have written down now. You do 1 minus 2 divided by 2 equals to cos A sin B. Cos A sin B. In this case, you realize you can't really substitute. Because what are the options available here? Cos with cos and sine with sine. Do you see that? So maybe it was not such a good option to to do a subtraction. Does it make sense?
Okay.
Let me think a bit. Sine A cos B minus cos A sine B is sine A minus B. That's correct. Then we have currently cos A cos B is 7 over 10. We have sine A sine B is 1 over 10. That's correct as well. What else do we have? Let me see again. Did I miss out something? Sorry. I forgot how did I approach this again. I am currently trying to find out what is sine A minus B. Sorry, let me see. Tangent A minus B. Okay, your approach was correct. Wait. Let me just write it down first. So we currently have sine A minus B is sine A cos B minus cos A sine B. And of course, the positive version. All right. Then you took, okay, maybe I'll call this star and double star. You took star minus double star, and then you divided by 2. That gave you the sine A cos B, right? Do we have sine A cos B? Let me just double check first. Did I do something wrongly? Was I supposed to take cosine? Cosine of A minus B. Is it possible for us to find out what is cosine of A minus B? Sorry, give me a moment to check this again. What was the strategy again? Right. I remember. Okay. Let me resume. Sorry, this question a little bit challenging, a little bit tricky. What we need right now is what? Sine A minus B, correct? Our objective. Here's the solution. Don't find sine A minus B. Instead, you try to find cosine A minus B instead. Does it even make sense? You find something related to it. Why? Because we are given cosine A plus B, cos A cos B, and sine A sine B. The product of cosine for 2 different angles, product of sine for 2 different angles is exactly the same as the cosine formula. Can you see that?
Okay.
So here, maybe we don't call this star and double star as the sign. Instead, we use cosine, okay? Write down the formula and then see a pattern. Is this okay?
You sub in here and here, and here and here, and you can sub in here.
Yes. Let's just not do the substitution first. Let's just do the subtraction in the algebra. I think it's a bit easier. This guy call it star, this guy call it double star. Then what can we do? We can do a subtraction star. Let me just double confirm whether subtraction or addition would be better. Or are both fine? Actually, both are fine. You can do addition or you can do subtraction. Both are okay. Let's see what happens if we do addition. We end up with cosine A minus B plus cosine A plus B. Then addition, the plus and minus will cancel off. You're just left with 2 copies of cos A, cos B. Is that okay? Then we also know what's cosine A plus B here, 3/5. We also know what's cos A, cos B here, 7/10. Finally, we're getting somewhere. We can now solve for cosine A minus B. It's just equals to 2 times 7/10, but you have to minus away 3/5. Is that okay? And 2 times 7/10 minus 3/5. Let's calculate that, and I get 4/5. Okay? How is that useful? I want to find sine A minus B. Why did I bother finding cosine A minus B? Right angle triangle. Do you get what I'm saying? Do you get the hint?
Okay.
Treat A minus B as one lump, one single angle. Like call it theta or something. So it's sine theta. You have cosine theta, you want to find sine theta. What do you want to do? Draw a right angle triangle. The angle is A minus B. And then fill in the rest. Go, go, go. So what is sine A minus B? Ta-da! Correct. And then you're done. But let me just write it down. You have to clarify first. Should it be a plus sign or minus sign? How? Plus or minus? What did they tell you?
It should be minus.
They didn't really tell you anything. They only tell you A is a acute angle, B is a acute angle. So there's many possibilities for acute
positive.
89 can be A could be 89 degrees, B could be 1 degree. Then 89 minus 1. Okay, so A minus B is positive acute angle. But it could be the other way around. A is 1 degree, B is 89. So 1 minus 89 is negative 88.
Plus minus.
So plus minus are possible. No. There's only one correct answer. You have to look at cosine A minus B. Here we managed to deduce using algebra. Cosine A minus B is positive.
Positive.
So A minus B is in which quadrant?
I mean,
Cosine is positive. Means?
Here.
But then you want. Is that enough information to deduce it? Let me think. Actually, you're right. But there's supposed to be one answer only. Let me see. Cosine A minus B equals to positive 4/5 tells us it's in quadrant 1 or quadrant 4. Then is that enough? Wait, let me see first. Let me see. Cosine A minus B. Okay, I think for now we just keep it to plus minus. I need to figure out a reason for. I remember that the solution says there's only positive, but I need to figure out a reason for why the negative should be rejected. Can you think of a reason? meaning that A minus B must be in quadrant 1, not in quadrant 4. Can you see?
What reason?
I can't think of a reason. Let me see. It must be if it's a let me think. If it's quadrant 4, negative cos. Both A and B are acute angles. That's not enough information provided. Okay, I'll just edit the question. Can I edit the question? Help me to change the question. I want A minus B to be strictly more than 0. Add on this extra condition. Extra assumption. Can?
Okay.
So in combination, you know that it's in AC, right? Quadrant 1, quadrant 4. But now we also know this extra condition, A minus B is more than 0. So it means it cannot be what do you call it? It cannot be that we will have an angle in quadrant 4. Because acute angle minus acute angle, A being acute, B being acute, it cannot go until quadrant 4 anymore if you tack on this extra condition. So therefore, after adding on this extra assumption, only quadrant 1. A minus B angle can only be in quadrant 1. Therefore, just positive 3/5. Can? Let me just copy down this A minus B, the adjacent over hypotenuse is 4/5, then square root 5 square minus 4 square equals to 3. And then sine A minus B equals to 3/5. And finally, once we have this sine A minus B equal to 3/5, we can say sub sine A minus B equals to 3/5 into, what is it? Into equation 2. So what will we obtain? We'll get tangent A minus tangent B to be exactly equals to this fella here. But just erase the yellow highlight. Sine A minus B replaced with what? 3/5. So we write down 3/5. Maybe it's neater if we just bring the working down to the bottom. So we end up with this sine tangent A minus tangent B equals 3/5 over 7/10. Type in the calculator. 3/5 divided by 7/10 is 6/7. Are we done? Is that the final answer? Oh, now we have to sub tangent A minus tangent B equals to 6/7 into equation 1. What's 1? The original question. Remember this one? Okay. Then after that, we just copy down. So therefore, tangent A minus B will be exactly equal to tan A minus tan B all divided by 1 plus 1/7. But you can replace the numerator tan A minus tan B now finally with 6/7. And then you can just type in the calculator to get our final answer. 6/7 divided by 1 plus 1/7, and I get 3/4. Is that okay? Can? Okay, very good. Can. Yes, and then we are done. Oh, finally. Question 14, if you're interested, you can try. I will mark it for you if you try. Question 14, a bit difficult. Let's move on, okay? Moving on. What else? You haven't done any other exercises, right?
No.
Well, let me just show you the working. Are you copying down the notes or something? Oh. Okay. Yeah, can. So next exercise 9C is done. How about 9D and 9E? Should we go through those? Let me see. The questions are actually quite okay. Right? Have you taken a look at the questions? Go to exercise 9D now and question 2. Is it page 291? Cos 2a equals to 119/169. Let me just double check if the question is the same because I hope I'm using the same version of same edition of the book.
You said page 291.
Question 2, exercise 9B.
Cosine 2a equal 1191 over 169.
Very good, correct. And that A is acute. Find the value of part 1 tangent 2A, part 2 tangent A, part 3 cosine A, part 4 sine A. For this one, what is it? You need to use double angle identities. Maybe we just go through question 2 and see whether it's okay or not. If it's okay, then I may some of the questions already. Exercise 9D, let's take a look at question 2. So we start you off with not just cosine A or sine B or something like that. We start you off with cosine 2A. Then they also tell you that A is acute. So that means that 2A is question mark. It can either be still acute, it could be 90 degrees, it could be obtuse. Any of these are possible. This is quadrant 1, this is quadrant 2. Okay, any of this is possible. We don't know anything about 2A. Moving on, but it definitely cannot exceed obtuse. I cannot go to quadrant 3, quadrant 4. So anyways, moving on to part 1, we want to find tangent of 2A. So tangent 2A, you can treat this 2A as a single lump. What is your first reaction when you see tangent 2A?
Double angle.
So this is when it is a bad idea to use double angle. Do you know why? Because the question, look at what's given.
Cosine 2a.
The angle 2A is the same, right? So instead of using double angle straight away, how about if we split it up as sine over cosine? But what's the angle? Angle here, here, and here must all be the same. So it's sine 2A over cosine 2A. Then you see, denominator can directly substitute, right? 119 over 169. Less work to be done if you did this. You do double angle, you need to do more work. Still possible, just more long-winded. And you need to figure out what's tangent A. Yes, correct. Draw right angle. And the angle, is it A or 2A? 2A, exactly. Adjacent, hypotenuse, how to find the other length. Is it 120? Okay, then what's sine 2A now?
Sine 2a is 120 over 169.
Exactly. Anything to cancel, 169 cancels. Final answer, 120,119 over 119. Easy, right? Good.
Okay.
Then how about part 2? Tangent 1A. Now.
Double angle.
On which one? So you're gonna split this into half A? No.
Wait, tangent A.
I'll give you a hint. Start with tangent 2A, which is really later. We already know it's 120 over 119. We can substitute at the left hand side. But on the right hand side, what can you split it up as? Oh, I need to show the formula. Is it? Wait, let me just copy the formula down. Yeah, here. Okay. What's tangent 2A?
Two tangent A over 1 minus tangent square A.
Exactly. But then what do you realize? The left-hand side is just a number, then the right-hand side involves tangent A and a tangent square A. When you see square, what do you think of? If I just let x equals to tan A, x equal 10a. What kind of equation is this?
Quadratic.
Exactly. So always so do you notice the pattern already? No matter what question, like for example, e power 2x plus 2e power x plus 1 equal to 0, even though it looks like a very weird equation, the moment you see a square, you must think, let y equals to something, then you get y squared plus 2y equals 2y plus 1 equal to 0. You always go boil back down into what kind of equation? Quadratic. Okay, it's a very common pattern. You'll see this all the way forever and ever. You'll just keep on appearing. Cannot avoid one. You cannot escape from the quadratic equation. So now you have to multiply, cross multiply, right? So 1 minus x squared equals to 2x times 119. All right, then 120 minus 120 x squared equals to 2 times 119. I need a calculator for this. Actually, maybe you don't need, but it's all right. Just use a calculator. So 238x. I hope you're not confused by the x and my times symbol. Maybe I should. Okay. Let me just use a curvy x. Is it better? I hope.
Okay. Help.
And then just minus 120x squared minus 238x plus 120 equals 0. Use calculator. Negative 120, negative 238, 120. And then you get, exact value. X equals to 5 over 12 or x equals to negative 12 over 5. So what is x? It's tangent of A.
Reject the right.
Why?
Negative.
Well, so is it because it's negative then you just reject?
No.
Then what's the reason?
Because angle A is acute, therefore quadrant 1, therefore should be positive. Therefore reject.
Yes, correct. Angle A is an acute quadrant 1 angle, so tangent A should be a positive. More than 0 contradicts with a negative value. So you have to reject the contradiction. Out. In. Answer. Okay. So that's how you solve it. Yeah. Actually, a little bit challenging. How about part 3, cosine single A? So maybe we collate all of the things that we have so far. We got cosine 2A 119 over 169. We got tangent 2A is 120 over 119. What else we have?
Tangent
A 5 over 12. What we want to solve for? Cosine single A.
Can't you just do a right angle?
Exactly. Yes, just use the right angle. So angle A here, use the single A one. So opposite over adjacent. Then this one is 13. Yes. So cosine A is
12 over 13.
very good. Let me just show you a more long-winded way to do it. If you want to use double angle. Okay, cos 2A, if you recall one of the formulas, is 2 cos square A minus 1, right? Yes? No? 2 cos square A minus 1. Then you can just use it. So it becomes what? 2 cos square A minus 1 will be 119 over 169. Okay, I'm using the double angle formula for the cosine 2A here. Can? Maybe, okay, wait. It's a bit confusing when I write it directly below cos A. I'll copy down the equation here. And then I proceed to substitute the left-hand side cos 2A with 2 cos square A minus 1. Then from there, you can make cos square A the subject, plus 1 divided by 2. So you end up with something, what is it? 119 over 169 plus 1 divided by 2 is 144 over 169. And then finally, if you want to solve for cosine A, you take a square root. Okay? Take a square root, plus, minus. But you have to reject which one? Reject. Negative. Why? Mic test, I can't hear you. Can you hear me?
Quadrant 1.
A in Q1, cosine A should be more than 0. Okay? Because this 2 dot at the top and then dot at the bottom means because. It's a lazy notation. Okay, so anyways, it's so therefore cosine A can only be the positive square root 144 over 169, which happens to be also 12 over 13. Okay, this method will also work using algebra. Clear?
Okay.
Very good. Yeah, so all the identities are consistent. You can use any one you like. Any one you like. Of course, the most efficient way is to draw right angle and figure out the quadrant. Part 4 is what? Sine A. And of course, 5 over 13. Yes. Good. I'll just squeeze it in here. Part 4, sine A, opposite over hypotenuse, 5 over 13. Yes. Good. You can also go and use cosine 2A, replace with 1 minus 2 sine square A, and then you solve for sine square and you take a square root, reject the negative. You can still get sine A equal 5 over 13. Do you need me to show you that?
No.
Or can I skip? Don't need, Yeah, I'll just write down a short description. Can also use cos 2A equals to 1 minus 2 sine square A formula. I can't show the formula on the same page. Yeah, here this guy, right? And then you just solve for sine square, take a square root, plus minus, reject the negative. You'll still end up with 5 over 13. Okay, moving on. So anyways, let's see. What's the next question I assigned you? Question 3. I found that interesting. You are given tangent A equal to half. You want to find the value of tangent 2A and then find tangent 3A. How do you find tangent 2A? Tell me your strategy.
How do you find tangent to A?
Yes. Question 3 now. Exercise 9D, question 3.
Mm-hmm.
How? Yeah, just use the double angle formula. Okay, very good. Then just fill in the blank and you can get the answer. Let's just do it right now. This implies tangent 2A equals to 210A over, sorry, I'm not showing the formula. Is that okay?
Yep.
Can okay, 2 times half over 1 minus half square. And this is just 1 over 1 minus 1 quarter is 3 quarters. So that's just 4/3. Very good. Now, how do you find tangent 3A? You got tangent A, you got tangent 2A. So of course, I hope you can see the 3A is very big. You can split up as what?
2A plus A.
Exactly. And then use the formula for expansion. Just to save some time, I'm gonna do it for you. So this will be tangent 2A plus tangent A, all divided by 1 minus tan 2A times tan A. Right? Is it okay if I don't show the formula?
Yeah.
I hope you have a reference on your phone or something. Can save some time. Okay, then you realize, oh, tangent 2A, tangent A, tangent 2A, tangent A, you can substitute the values with whatever you have already found. Maybe I'll just highlight it. Green color will be these two fellows. Yellow color will be those other two fellows. That's a plus sign in between, not to be confused with the T in the tangent. And I'll leave you to substitute on your own. ... Is that okay? Can?
Okay.
Just replace the 4/3 and the half. Very easy. Blue color is always standard question, quite easy, right? Moving on. Now, what was the other interesting question I wanted you to try? Question 459. 4, 5, and then question 9. 4, 5, 9, 13, 14. Right. Okay. Take a look at question 4 then. Question 4. What we have? Cosine 2A equals to 2/3. So again, we start you off with a double angle. They tell you A is acute. So you know sine, cosine, tangent of A will always be positive. What else? You want to find the value of sine 2a? Sine 2a. Do you want to use double angle?
No.
No, because there's already 2a. So you use right angle triangle. Nine minus 4 is 5, so square root 5. So sine is opposite over hypotenuse, square root 5 over 3. Yeah.
Mhm.
Very good. Part 2, cosine A.
Okay. Cosine A. Double angle formula.
Very good.
Cosine 2A equals to what? Is it? Yes. Wait, but what can?
There's only 3 versions.
Yeah, but
You want cosine A, right? You already know cosine 2A is 2/3.
cosine square A 2 minus 1.
Very good. If you use any of the other options, you will introduce a sine square, which is not very good because you don't know what is sine square A. Right? So this is a good option. Okay, then just solve for cosine square. I'm not gonna do the substitution with x. Sorry?
Yeah, okay.
Oh, fast. Okay, so plus 1, then you divide by 2. So 2/3, you plus 1, then you divide by 2, you get 5 over 6 for cosine square A. And then after that, you take a square root. So cosine A equals to positive square root 5 over square root 6. You can rationalize. Then you get square root 30 over 6. Square root 30, let me think a bit. What can I divide by?
2 times 3 times 5.
Okay, can't really simplify it. Okay, never mind. That's all we have. Square root 30 over 6. Positive square root. Positive. Why? I'll leave. I'm sure you know, because A is acute, quadrant 1 angle, cosine A must be a positive value, no negative root. Can? I'll just write that down. I'm sure you know the reason already. Moving on, part 3. What is part 3? Tangent A. Once you know cosine A, again, right angle, draw the angle A, adjacent over hypotenuse. So square root 30 over 6. Last thing must be 6 square minus square root 30 square, take a square root, which is square root 36 minus away 30, which is square root of 6. Is that okay? Very good. Then what is the tangent of A? Tangent A must be opposite over adjacent. So square root 6 over square root 30. Combine into a single square root 6 over 30. What's 6 divided by 30? 1 over 5. So square root 1 over 5. You can split out as square root 1 square root 5, which is 1 over square root 5. You can rationalize, multiply top and bottom by root 5. You're left with root 5 over 5. Is that okay?
Yep.
You know, that is part 3. Moving on to part 4. Part 4 wants tangent half A. Wow, how? Oh no, half A.
Double angle.
On which one?
You use tangent A.
Very good. Yes. You start with the bigger angle, then you break it down into the smaller angle. So okay, what is tangent A? Other than the fact that it's root 5 over 5. I'll use 1 over square root 5 instead. Oh yeah, by the way, usually when you're solving problems, advice for you, the final answer, you need to give it in rationalized denominator format. But the problem solving aspect, right? When you want to substitute with a value, you usually use the non-rationalized version. It will be easier. The questions are typically designed with not rationalizing the final, the expression in mind. That's a pattern I found, okay, to save time. Don't need to use the rationalized version when you are doing part 4, part 5 onwards. But for the final answer for part 3, after you get 1 over root 5, for exam purposes, you may, depends on your teacher in the future or the exam you're taking in the future, you may need to rationalize as the final answer. That's the requirement in O-level A-Max. Rationalize. But anyways, moving on. How tangent A? Expand for me.
Tangent A equals to
Think carefully. Times tangent of what?
2 tangent A over 2
Good. Halfway.
over 1 minus tangent square A over 2.
Very good. Yes, you have to know the relationship. Here is big, there is small. Maybe I'll just write it down big and then small. How do you go from big to small? Divide by 2. Okay? Can. Very good. So 1 over root 5 equals to 2 times. Okay, you know what? Just to make my life easier, I'm just going to say let x equals to tangent A over 2 so I don't have to keep writing it. So this becomes 2x over 1 minus x squared. Again, what do you have to solve now? What kind of equation?
Quadratic.
This is a quadratic equation. Then I'll leave that to you to solve on your own. Is that okay?
Okay.
And then remember, quadratic will have 2 answers. Which one do you reject? Reject? Negative. Why? Because eventually you solve for x equal tangent A over 2. If A is acute, what does it mean about A over 2?
It means it has to be positive.
I mean, the angle will also be acute first, then because of that, the tangent will also be positive. Okay? Can acute is quadrant 1. Yeah. Okay, yeah, I'll leave that to you for part 4. Moving on, this is question 4 only. Oh my, I gave too many homework questions already. Question 5, I think it's the same. Question 5. Do it yourself, okay?
Okay.
Yeah. Question 9. Go on to more difficult questions. I'm sure you can do those already right now. Question 9. This one finally we get to see some radians. Okay. Tangent x equals to -2. We got pi over 2 less than x less than 3 pi over 2. If you are not familiar with radians, convert into degrees to keep track of what's going on. So 90 degrees to 270 degrees is actually over here or here. So it's quadrant ASTC, quadrant 2, quadrant 3, right? Yes. Okay. So tangent x is negative. Does it make sense? Inside here.
Okay.
Yes. That means the angle x is actually where?
That means the angle x is either second quadrant or third quadrant.
That's from this guy, right? Okay, wait. I write it separately. From this guy, yes, x is in Q2/Q3. But what about tangent x is negative?
Is in quadrant 2.
Yes, because or more generally, without looking at the domain, from just looking at tangent x equal -2, you should be able to tell using ASTC that x is in Q2/Q4. Combining them, Q2 or Q4, Q2 or Q3 implies that x is in Q2 only. All right, yeah, good. So how to continue? You want to find cosine 2x, tangent 2x, sine 4x. How to find cosine 2x from tangent x equal -2? If you look at the formulas for cosine 2x, double angle, right? It's cos square x minus sine square x, or 2 cos square x minus 1, or 1 minus 2 sine square x. They involve cosine and sine, but here they gave you only tangent of x. So what should you do? You need to convert into sines and cosines. That's what you need in order for you to use the formula. Is that too fast? Do I need to show the formula?
Nah, it's okay.
Don't need. Okay, thank you. Save some time. So tangent x equal -2. What can you draw? My favorite triangle.
Right angle.
Right angled triangle. So angle x here. Please ignore the minus sign. So this is -2/1. Opposite over the adjacent 2/1. So 2 here, 1 here. Hypotenuse must be 1 square 1, 2 square 4, 1 plus 4, 5. So square root of 5. Using Pythagoras theorem, 90 degrees there. So cosine x is what? 1 over root 5. Sine x is what? Opposite over hypotenuse, 2 over root 5. Is this correct?
Yeah.
No, not enough. Angle x is in which quadrant?
Or negative.
Q2. So Q2 only sine gets to be positive. Cosine must be negative. Trick question, this one. Very tricky. Must make sure you know the, what do you call it? The sign, right? As in SIGN. Okay, can ASTC basically. How do you find cosine 2x now? How do you find cosine 2x? Use either one of the formulas, or let's just use this one, cos square x minus sine square x. What would this be equal to? Negative 1 over root 5 bracket square minus way 2 over root 5 bracket square. Luckily, there's a square here. So even if you forgot to put the minus sign over here, you square it, the value will still be the same. At the end of the day, you just get 1/5 minus away 4/5, which is negative 3/5. Can? Okay, very good. Now, how about part 2? What's this? Tangent 2x. You already found one involving 2x. What do you have to draw again? Do you want to use double angle identity? You can, but what's a smarter way?
Right angle.
Right angle again, but this time the angle, is it x?
No, 2x.
2x. So you see minus 3 over 5. Do you care about the minus?
No.
No, ignore it. Then 3 and 5. So adjacent over hypotenuse, 5 square minus 3 square, take a square root, it's a 4. Okay, then what is tangent 2x now? Tangent 2x.
Tangent 2x. Now. Opposite over adjacent, 4 over 3.
4 over 3, but then plus or minus?
Minus.
Here you have to be careful. X is in Q2.
But 2x.
So 2x, a bit vague actually. Let's think about what it means when it's in Q2. Q2 actually means that the angle is more than 90 degrees, but less than 180 degrees, right? So if you times 2 to the inequality, positive 2 means the inequality direction doesn't change, but this becomes 360, that becomes 180, which means that now 2x is in either Q3 or Q4, right? Here.
Yeah.
ASTC. So tangent, sometimes it can be positive, sometimes it's negative. Then what does it mean? It means that the answer is ambiguous. Right or not?
Yeah.
But let me think a bit. Is there a way to make it not plus minus? There is. Take a look. Cosine 2x is negative 3/5 by the formulas. Right? The formula will always be correct. Cosine 2x is negative. What can we deduce from 2x about this for 2x?
It means that it's either quadrant 2 or quadrant 4. I mean quadrant 2 or quadrant 3.
Cosine is negative means it's quadrant 2 or quadrant 3. That is correct. Yes. But what else do we know about 2x? It's actually, it must obey this rule here. 180 more less than 2x.
Either quadrant 3 or quadrant 4. Therefore, it is in quadrant 3. Therefore, tangent is positive.
Very good. Yes, exactly. Let me just draw the reason like this and like this. Implies that 2x only in quadrant 3. This implies it has to be positive. Don't need plus minus. Always a plus because of the reason here. 2x in quadrant 3. Okay, good. Now moving on to the last part. Part 3. What is what's this guy? Sine of 4x. Sine 4x. Whenever you see these numbers, 2, 4, 8, 16, 32, what are they? What's the pattern?
Times 2 times 2 times 2 times 2.
So there's doubling of the angle. Means you can use what formula?
Double angle formula.
Exactly. But here you can think of it as 2 times 2x. So you can rewrite it as 2 sine 2x times cos 2x. Right? And you already have a right angle triangle here. You also know that 2x is in quadrant 3. So how? Proceed. 2 times what sine 2x? Look at the triangle.
Sine 2x is 4 over 5. Then
Positive or
cosine
negative? Plus or minus? Think of it.
I mean quadrant 3, therefore is negative.
Very good.
Then
Negative 40.
cosine 2x is negative, so it cancel each other out.
Yes. Correct. So adjacent is 3/5, right? So what is the answer? 2, 4, 8, 8, 3, 24, 5, 5, 25. Positive answer. Yay, done. Still not done. Wow, I gave too many homework questions already. So sorry. Okay. Try question 13 and 14. Your homework for the remaining ones. Xingli AMX textbook exercise 9D, question 13 and 14. And 9E, I also gave question 1BHI. The ones I found interesting. I think you should try. 1IK, what else? Question 2BHK and question 3. Okay, the others. I am so sorry. I did not have time to go through R formula yet, so I cannot give you homework on that. If you want, you can go and read page 295. Read page 295. Okay, of the textbook, right?
Yeah.
Can Yeah, then you can. Then I'll explain it next week on how to use on R formula. And that will be all for today.
Okay.
Okay. Thank you.
Thank you.
All right. Bye-bye.
Bye.